So this week 3, we introduced some new topics. Okay, so this topic actually is extension from the equation. So right now when we're talking about the parentheses, something like when we talk about something like the numbers have the parentheses, you need a distributor inside, right? To get rid of the parentheses, right? In this kind of case. So what about some situations? Actually, they have the absolute case, like this one, all right? Absolute x equal 5. So we need to get rid of absolute as well, right? First, how we get rid of absolute? So let's, before we begin to get rid of absolute here, let's think about something like what we learned earlier. Absolute fraction. We say when a number was something like 5, absolute itself equal 5, right? When we negative 5, absolute became the number of it is opposite to this one, became 5, right? Absolute 5 equal 5. So this 5 actually is the absolute value, is opposite of the inside when the number here is negative. When the number inside this absolute is positive, they are equal itself. When the inside the number is 0, of course it equals 0, right? When the inside the absolute number is a negative number, after absolute, they became the positive. Just the is positive is the opposite side of this negative number, right? So we can summarize like this. So if they are a number, if the a is greater than 0, so equal a. If the a equals 0, of course it is equal 0. When a is a negative number, this is equal negative a. You know what I mean? So you can see here. So you can see here this quickly, right? So if the a is a positive number, equal itself. If a equals 0, it's equal itself. I mean, it's still equal 0. If a is less than 0, is the opposite number of this number, right? Inside is a negative. Then it became positive, so it's opposite, right? So the same here. So go back to see this situation. So if say absolute x equal 5, so x can be what? Can be 5, can be negative 5. Sometimes we write like this way, positive 5 or negative 5. All right. So x can be 5 and can be negative 5, right? Can be negative 5. When negative 5 equal 5, you can got positive 5 is 5. When absolute, what do we often use this number? We use description. We know when we describe x, right here is 0, 1, 2, 3, 1, 2, and negative 1, negative 2, negative 3, right? We use absolute is used to describe the distance, something like say 3 to 0. What's the distance between these two? What's the distance between these two? Actually is 3, right? So how we describe these 3? We use the beginning number and the end number. We can use the 0 minus 3, right? But when this one equal negative 3, but actually number is 3, so we add absolute. The distance between 0 and 3 is the absolute number here, so you got 3. But sometimes you can say beginning from here, end of here, you use the 0 minus 3. If you beginning from here, end of here, so you can 3 minus 0, so you also got 3. So absolute, this number, you just get rid of which one is beginning. Doesn't matter, right? Is 0 is beginning or 3 is the beginning, doesn't matter, right? So you can got the same distance because of their beginning and the end. I mean, the two end is the same, so the distance should be the same. So absolutely help to answer these kinds of questions. they use to describe the distance. So the only thing is when the inside number, if they are positive number, you just need equal itself. When they are negative number, when they are absolute, they will become its opposite, internal part opposite, right? So keep this in mind. This is super important, right? So you get when you something like A, you want to get this absolute, you need to know what number inside is positive, is 0 or negative. So we combine the first two. If they are greater or equal than 0, they equal itself. If they are less than 0, we use their opposite. Okay, so something like say what x inside equal 5. So we can say if the x is a great number, is greater than 0. If x greater than 0, we can get rid of this one, right? So x equal 5. So you can, or you can say x greater or equal than 0. So you can, if, so these kinds of absolute can be get rid of. So you can directly get these answers, right? If x less than 0, so this, when we get rid of this one, they became negative x equal 5. So x equal negative 5. So we have two solutions. One is x equal 5. The other one is x equal negative 5. So combine these two. You can, of course, say x equal positive or negative 5. Okay. So you can see one step you can go here. If someone asks you, say absolute x equal 5, you can get direct x equal positive or negative 5. That's it. So just remember this one kind of rule. So if we say x equal a is a positive number. So x actually can be equal positive or negative a, right? Right. So right now I just change 5 with a. A is a positive number. So x actually can have two solutions of this one, right? Right. Okay, so let's see more example here. More example. See this one. This example. So 4 times x plus 2 equal 24. So we consider this one as a parenthesis, right? Consider is parent, but we cannot distribute inside right away. We definitely can distribute. We try to consider all absolute number, this one as a unknown things first. All right. First, we consider this is a unknown unit first. So what do we need to do now? We consider this part is a unit, something unavailable. We not try to get rid of absolute value right now until last step. Only this part in one side. So what do we need to do here is we can both side divide 4. Both side divide 4. All right. So the left behind is this one, right? Only left behind this one. Right part equals 6. All right. So right now we want to get rid of absolute. So you can see x plus 2 can be equal 6, or x plus 2 equal negative 6. Do you notice that? We consider this one as the one part, right? So when we get a rid, they can be possibly 6. After absolute, they got 6. They can be negative 6 after absolute. They can be negative, can be 6 as well, right? Absolute, they became 6. So all right, so you can find solution is here is both sides minus 2. So here got x equal 4, right? So both sides minus 2. So x equal negative 8. So have two solutions, right? One is 4, one is negative 8. You can put it back to check it. What about left part? 4, this is 4 plus 2, right? So left part, this is left part. So left part equal what? 4 times this 6 absolute became 6, right? 4 times 6 equal 24. Right part 24. Makes sense, right? So this is a solution. What about this situation? When x equal negative 8, What about the left part looks like? Looks like 4 times -8 plus 2. -8 plus 2 equal -6, right? 4 times, after absolute, here became 6. So 4 times 6 equal 24 as well. Right? Also makes sense, right? So both answers, that's 2 answers. Okay. Sounds good? So get rid of the absolute, not try to, like parentheses, get rid of it at the first step, as most of the time we do it at the final step. Actually looks like in the final step. All right, let's see some more example here. See this example. 5 equal, all right, so you can see what do we need to do? Both sides -8. So you can see here, say -3 equal x plus 2. Oh no, do you see what's going on here? X plus 2 absolute. So you can see actually x, any distance always greater or equal than 0, right? So here x plus 2 equal -3. This part, right part is greater or equal than 0. Left part is less than 0. So obviously this equation, this means no solution, no solution. No solution, because of left part less than 0, right part greater or equal than 0. So there's no solution for this part, right? So no solution, no solution. All right, let's see the third example. Absolute 3x plus 1 equal 13. Same here. So we consider, so if inside this part is greater than 0, so this part we can get rid of the absolute right away, right? Equal 13. So x equals what? So we can just get a solution like the week 2, what are we learning, right? Both sides -1. So 3x equal 12. So x equal 4. Both sides divide 4, right? Both sides divide 3. So x equal 4. So let's check it. 4 put inside, 3 times 4 equal 12. 12 plus 1, 13. Absolute, still 13. So makes sense. So we only get one of them, right? We need to say if this one less than 0, it's a negative number. So internally became the opposite, right? Opposite became like this. When we get rid of absolute, they became like this. All right. So became what? -3x minus 3 equal 13. So -3x equal 16. X equal 16, -16 over 3. Right. So there's 2 solutions. You can put this one back to check it. Actually, I do something wrong here. Can you guys find out what I'm doing something wrong? Actually, I copied wrong one. Copy here. I do something wrong here. Actually, I need to correct myself. Here, when I distribute inside -3x, here is -1, right? -1. So here is 14. 14. So it should be 14 over divided -3. Okay. So this is second situation. So we have 2 situations. We need to judge inside the absolute is a positive number or negative number. All right. If they are positive number, you can get absolute directly. If they are negative number, you can see I've added one negative in front of here. All right. Okay. All right. So let's move on. Let's move on this one. This question, this example. Let me use different colors. Make sure you guys can figure out which one by which one. All right. So this one. So this one. Firstly, we both sides, we let the absolute containing the absolute cancel expression in one side and move the rest to the right side. So you can see x minus 12 minus 3, both sides plus 3. So you got 14 here, right? So actually we can just break it down here. So x minus 12 can be positive 14. They can be positive or can be negative 14, right? All right, so both sides plus, so both sides plus 12, both sides plus 12. So you can see the description here. So x, the left part is only left x. So they can be, when this part, they became 26. When this part, it became negative 2. So have two solutions. One is 26, one is negative 2. One is 26, one is negative 2. All right, sounds good. Anyone understand here? Okay, let's see this one. Let me move here a little bigger. All right, let's see more examples. So this one. Okay, so see this one. All right. So firstly, we consider this is a one part. So one variable, right? We cannot get rid of this parenthesis right away. We need move and consider this as a expression or as a variable by itself. We cannot get rid of parentheses quickly, right? So let's move everything to the left and keep this part in the right. So both sides minus 30, right? So you can get here is minus 14 equals 7, p plus 3, right? Both sides divide 7, both sides divide 7. So you got a negative 2 equal p plus 3. So you can see this absolute expression equal negative 2. So actually you can find out this is similar like this situation. Because the right side always greater or equal than 0. Any number after absolute is greater or equal than 0. The left part is less than 0. So it means no solution. No solution for this expression, for this equation. Okay, let's do a little bit further. Let's see the example here for this part. Well, next one here, 15 here. So with both sides minus 3. So goes absolute 7m equals 70. So actually we can quickly find out that 7mx equal positive or negative 70, right? Both sides divide 7. Both sides divide 7. So m equals positive negative 10, right? One is positive 10, one is negative 10. They have two solutions. All right, let's see 16 examples. Similarly like here, how we get rid of absolute. So let's move everything to the right first. So absolute 7x over 7 equal positive 1, right? Both sides plus 7, both sides plus 7, so plus 1. So x over 7, we'll try to get the absolute right now. So they can be positive 1 or negative 1, right? So both sides times 7. So x can be equal positive 7 or negative 7. So have two solutions, right? See number 17 first, 17 here. So both sides times 8. So you got is negative 9 plus v equals 24, right? All right, so we got a negative 9 plus v. They can be positive or can be negative 24, right? So we both sides plus 9, both sides plus 9, both sides plus 9. So here 24 plus 9 equal 33. negative 24 plus 9 equal negative 13, right? One is negative 13. One is I'm sorry, negative 24 plus 9, negative 15. Negative 15. So one of the answer is 33. One of the answer is negative 15. Okay. So you can see what do we find out? We move like an absolute value equal something first, and then we get rid of the absolute value. They can be positive and can be negative of the part, right? All right, let's see 18 here. With both sides, divide negative 10, divide negative 10, right? So v plus 2 absolute value equals 7. So actually v plus 2, they can be positive 7 or negative 7, right? So v equal, when the 7, so it's minus 2 became 5. When the negative 7, minus 2 became negative 9. So they have two answers. One is 5, one is negative 9. All right. So partially of this work, homework, we will close about how to get the solutions when the equation have absolute value in the equation. Okay. So this is the first topic we talked about this time. We go to some more. We know when we talk about equations, we often met a lot of reality problems. We need to use like this kinds of equation to get the solutions, right? Right? So we need to use that. How to use these kinds of equation to find solutions in the reality. We can make a lot of different kinds of problems possibly in reality. All right. So let's see. Let's see here. There's some example of actually problems we met in reality. I try to use some more examples to explain the situation. So in this reality situation, we need first thing, we need to build the equation. We need to build the equation. Build the equation. Because earlier, what do we find the solutions? The equation already existed there. We didn't build it, right? So you just find the solutions. Use the proper equation properties to find the solutions. But when reality problems, what do you need to do? You have to build a equation, and then find solutions. Use the knowledge, what are we learning? All right, so first build the equation. Build the equation, you need to use the knowledge about how they describe to build this equation. All right, let's use the first example here. Build the equations. Okay, find an unknown number, twice a number, but nobody told us what's the number are, right? So we consider this number is unknown. Twice a number means 2 times of them, right? Add to 7 is the same. Means something equals something, right? Is the same as 3 subtract from the number. So 3 subtract from the number. The number is a number here, right? 3 subtract from the number. So we build this equation, right? Find a number. So the number here is unknown. So you can see how to build the equation. We need to read it. At least read it twice before how to build this equation. All right. So let's read it one more time. Twice a number. You can see this number didn't tell you earlier. Nowhere told you. This just show up first time, right? Number, we don't know. So we give their unknown. Let's say it's X. Twice the number. Twice a number, it means 2 times the number. Add to 7. They add 7. Is the same. Is the same means something equals something, right? Same. So this is the same as the least part. This is the same as the least part. So they can build the equation, right? As the 3 subtract from the number. So take 3 away from this number, right? So take 3 away from this number. Find the solutions. So let's see, right? Let's see. So we build the equations. So how find a solution would be easier for us because we learned the equation before. Both sides minus x, both sides minus 7. So you kind of left part became x, right? What about right part? Negative 10. So we find solutions. Easy. So only thing we need how to build this equation, right? All right, let's move on next. So actually, just like I say, when we build these kinds of equations, most of the time we will meet a lot of kinds of formulas, be honest, in your reality. You guys maybe learn some basic algebra and some speed kinds of knowledge here. So I list just some of the information here. So make sure you guys can, if in some cases you maybe have to use it. Something like rectangular. In rectangular is the length and width. This is rectangular. The area of this one, the area of this rectangular, the relationship is the length times width, right? This is length. We use the L, the width, we use the W. So L times W, right? This is everyone learned it before, right? And second one is simple interest. Simple interest is including the principal time rate time. This multiplied rate multiplied time. So interest actually including the amount of money you borrow and the rate, the time, all right? And perimeter rectangular, actually perimeter of the triangle A, B, C, perimeter of length is 3 sides plus together. This one everyone know that, right? And the distance is equals to the rate in time. Distance is rate in time. Something like you'd say 60 miles per hour, you drive 2 hours of length, right? So you get 60 times 2, right? And volume of a rectangular solid. Right? So here's, suppose here is A, here is B, here is H. Sometimes L length, width, or H. So volume of this one is the base. The base is the L times W. L times W. And time H again. You got the volume out of here. Right? And the temperature, F to the C, the transition of length is F equal 9/5 times C plus 32. And sometimes you can say C equal F minus 32 times 5/9, right? When you do the temperature from the F to the C to the cells, you need to transform this kind of equation. Right, so this is a basic, very basic information. You maybe learned from somewhere else, from the algebra. I mean, from the geometry already. So some of this formula will be used. So this is a very basic part I put it here first. So let's move on. So let's see more examples about the equation and problem in our realities. All right, so something like this one. Quickly, this one, all right? We'll just take 2 more minutes maybe. Find the length of a board. A bachelor wood sticks of a common used for building models. For example, building models. A 48-inch wood stick is cut into 2 pieces. So this is a stick. This is 48 inch totally from here to this end. They cut it into 2 pieces, all right? So that the longer piece is 3 times of the shorter piece, all right? So find the length of each piece. So that's what I would say. So the longer, suppose this is longer, and 3 times of this one. So we suppose this one is x. So this part with 3x, right? This is 3 times to the longer one to the shorter one. But the total of length is 48. So it means 3x plus x totally together is 48 inch, right? So you got here is 4x equal 48. So x equal 12. So this x is 12 inch, right? So here is 36 inch. So longer piece is 36 inch, shorter piece is 12 inch. So the most important, we need to build this equation. All right, let's take one more example before we end this classes was over, okay? All right, see this one. Find an unknown number. Well, we talked this already, right? No, we didn't talk this yet. Twice the sum of a number in 4. Twice what? Twice the sum. Twice a sum. Sum is something plus something. A number is unknown. We give the x and 4. Twice a number in 4. The sum of them is the same. Means equal as 4 times the number decreased by 12. Find the number. So the same is like here, right? Let's do that again. Twice the sum of what? Twice the sum of the number in 4 is the same. It means equal as 4 times the number decreased by 12. So we build the equation here, right? Okay, so that would be after the build the equation. So we can say this is 2x plus 8 distributed inside. So you got 4x minus 12. Combine like terms, right? So move everything to the left. So minus 4x, we make this disappear. Minus 8, make this disappear. So reorganize here. Negative 2x equals negative 20, x equal 10, right? Both sides divided. Right? Okay, so today we talk 2 of them. One is talking about equation contain absolute value, absolute kinds, how we find a solution out of there. Be careful about that one. So they always have 2 solutions most of the time. And when there was absolute value equal a negative number is in this situation, if this part is greater than 0, this part is less than 0, so they have no solution. Some typical situations show up here, right? Second topic, we're talking about actually problems with the algebra equation. That's multis. I will send this out as a homework as well. Okay, like this one. Actually, I bring pretty much of them to write here. I assign as a homework to you guys, so you guys can finish them and practice. All right, that's all for this week. Any questions? No? Okay, so that's all for today. Thank you so much. See you next week.
Thank you.